All right, question number 1. We want to know which of the following are criteria for binomial probability experiment. Okay, so we're going to select all that apply. So the trials are independent. This is one of them from the properties in the text. There are 3 mutually exclusive outcomes, so that's not going to be true. We only need 2 binomial, like a bicycle, 2 wheels. Each trial depends on the previous. No, each of them is supposed to be independent. The experiment is performed until a desired number of success is reached. No, we're going to have a fixed number of trials. The probability of success is different for each trial. No, it's supposed to be the same. So F says the probability of success is the same. Yes. There are 2 mutually exclusive outcomes, success or failure. Yes. The experiment is performed a fixed number of times. Yes. So these were the 4 properties that we saw in the text. And then question 2, it says determine if the following statement is true or false. So in binomial distribution, NCX represents the number of ways of obtaining X successes in a trial. So this is going to be true. Let me show you how this works, because I want to spell this out for you a little bit. So this NCX is called combinations. Okay, number of ways of getting X success. N number of trials. X number of success. Okay. So the way this formula works, NCX, this is equal to N factorial divided by, you're going to subtract these two, N minus X factorial, and then times another X factorial. So if you've never seen factorial, exclamation point in math, let me show you what that means. If I had any number, let's just say 5, and I was doing 5 factorial, that means 5 times 4 times 3 times 2 times 1. So whatever number you start with, you multiply each successive number going down one at a time until you get to 1. So 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is still 120. So this would give you 120. Also, an important note to know is 0 factorial is equal to 1 by definition. So if you have 0 factorial, that's equal to 1. Let me show you both of those in calculator. So if I turn this on and I hit the number 5, I'm going to go to math. I'm going to arrow over to probability. Option number 4 has that factorial. And I hit enter. And then I get 120. So even if you did 5 times 4 times 3 times 2 times 1, you get 120. So that will do it for you really quickly. And if I do 0, and then I go math, and I go all the way over to probability, and I do 4, I get 1. There's a little video in the bonus in our section that explains a little bit about a factorial. So if you want to check that out, that's extra credit when you see and respond to that. However, let's keep going. I want to use this and help you guys understand the number of ways of getting successes. So let's just say, for example, we're going to flip a coin 3 times. Okay. So when I flip a coin 3 times, I got 2 outcomes, tails or heads. I want to say that tails is going to be my success. So if I flip it 3 times, I can do tails, tails, tails. Or it could be tails, tails, and then heads. Or it could be tails, heads, tails. So I got heads, tails, tails. I'm going to do the mirror of this. Instead of getting 3 tails, I can get 3 heads. All of them can come up H. Or it can be H, H, T. Or it could be H, T, H. Or it could be T, H, H. So what I did is I started with all 3, and then I did the way to get 1 heads, and I did all possible combinations. Heads could be last, it could be in the middle, or it could be first. And then when you do the mirror image of that, you're going to get getting 2 heads when you do the opposite of the 2 tails. You got all 3. So there's 8 different ways this can happen. That should make sense, because if I'm doing the trial 3 times, each time I have 2 outcomes, heads or tails. 2 times 2 times 2 give me 8 total ways. So here's how we can look at this. When we talk about a binomial experiment, I'm looking for either I get a tails or I don't, and I want to count how many tails I get. So if I look at each of these outcomes, 3 is a possibility, getting 2 tails is a possibility, and there's a different number of ways for that to happen. Getting 1 tail is possible, or 0. So however many times I do it, I'm going to start from that being my max and 0 all the way down to 0. So I have 0, 1, 2, or 3 tails observed, if that's my success, getting tails. Now, how many times did we get 0? That means all of them came up heads. That happened once out of 8. How many times did we get 1? 1, 2, 3. That happened 3 times out of 8. How many times did we get 2? 1, 2, 3. That also happened 3 times out of 8. And then how many times did we get all 3 tails? This happens once. Okay, so we can count and we can see. Now I want to use this formula to show you how to come up with these numbers. 1, 2, and 3. It's going to give me the top. I'm not worried about the 8, but just the top number is what I'm looking for. So if I have 3 trials, because I flipped this coin 3 times, I would do 3 combinations of, let's say we want to find how many ways I would get 2 tails when I flip a coin 3 times. So here's the formula. Using the formula up here, which I kind of put up too high, we're going to do on the top 3 factorial. That's my n. And then n minus x, so 3 minus 2 factorial. And then times 2 factorial. Okay, so this is what that looks like. All right, so let's spell that out. This is going to be on the top 3 times 2 times 1. That's what 3 factorial is. When I do 3 minus 2, that gives me 1. So just 1 factorial is just going to be 1. And then 2 factorial, we're multiplying these 2 times 1. Okay, so notice 2 will divide by 2, 1 will divide by 1, so I'm just left with 3 divided by 1, which gives me 3. So when I do 3 flips and I want to find the number of successes being 2, it tells me that there's 3. So that's what this formula is doing. It's counting how many successes you will have if you have a fixed number of trials. So that's part of that formula. So anyway, this answer is going to be true.